Welcome back in a new video. In this video, we are going to learn about an collapsed as built, but for schedule delay analysis technique. So actually, it's you can say it is retrospective CPM schedule delay analysis technique that determines the earliest date that are required product completion activity or various milestone activity could have been achieved but for the honor cost delays. Okay, so that occur during the project. So the amount of honor cost delays are determined from the ABPF schedule delay analysis, quantify the contractor's entitlement to receive the compensable delays damages. Similarly, the analysis could determine the earliest date that the variance completion activity could have been achieved, but for the contractor cost non-compensable delays that occur during the project. Okay, so actually this method scheduling delay analysis is you can say it's typically more difficult to perform than the time impact analysis because most CPM software programs regard as a build date as historical events fixed on time. So as a result, most CPM software programs will not permit but for the analysis model to be run on a schedule containing the actual date. So let's start it. Collapse as built but for schedule delay analysis. Step 1, approved schedule as planned schedule. So let's open our schedule in P6. It's a small product. Okay, so as planned schedule. So how many days we have here? Plan 100 and 121 days. The second method, second step, baseline completed schedule with actual total duration. That is the as built schedule. So now let's open. Go to the products, and now you can see a baseline construction product as built schedule. Right click, then open product. So according to our this as build schedule, you can see it is completed. It has been finished, but you can see we have 140 days. So actually, the planned duration was 120 days, but it took 19 days more to complete. Okay, so this project actually took 140 days to complete. Okay, so plan was for 121 days, but actual are here 140 days. Step number 3. This has built schedule already including all the delay events which is documented in the here schedule table. So I have already added here the events. Okay, so activity name, activity ID, activity name, as planned duration, and delay and causes of delay, delay types, etc. So activity ID is here A1050. That is the excavation block A. Planned duration was 10 days. It took 5 days more to complete. So cause of delays, you can see here contractors unforeseen event during the excavation, and the excavation activity took 5 days extra to complete. Delay type, you can see excusable. Okay, so because it's a honor cause delay. Okay, so it's simple. You can say, right, you can write here the excusable cause delay. Okay, so next we have A1070 foundation shuttering block A, and as planned duration is the 10 days, and it took 2 days extra to complete. Okay, you can see here. So contractor had shortage of labor, and FTN shutting activity took 2 days extra to complete. And non actually it's a delay types here. You can see non-excusable and non-compensable contractor cost delay. Activity ID the 81140 ground floor block masonry block A. So as planned duration is 18, and It took 17 days extra to complete. Why? Because his here client had extra work and design was changed and ground floor block masonry work took more days to complete. Okay, so actually you can say excusable, compensable, and it's a honored cost delay. Okay, so next we have a 1160 ground floor finishing. So as planned duration was 50 days and it took 5 days extra. Paint material and plaster material and the labor was delayed due to the payment issues by the contractor. So delay types you can see non-excusable and non-compensable. It's actually it's a you can say the contractor caused delay. Okay, so now move to the uh, schedule. First let me show you, this was the documented in Excel table. Okay, so we have already added the events why they are late. Okay, so how many days they get late. Next, step number 4, create another as planned schedule which has a start and finish date look like as built schedule. The schedule is called as built calculation schedule. So go to the Primavera P6, go to the projects, and first we will make the copy. Like a right click, you can make a copy and you can paste. And first we will add the honor cost delay events. You can see here, right click, then open project. So here you can see we have added two delay events here. So honor cost delay events. So first one is the honor cost delay events for 5 days. You can see here. The second is here. You can see the ground floor block masonry work because a client added extra work. Okay, so how to add in this schedule? First, you can go to the project WPS. You can add here one more WPS with the name of honor cost delay events. Then go to the activities. Okay, so then you can add these two events here like this. Right click, activity details, and let me show you the relationships. Okay, so it's a delay in excavation and its a predecessor is the start block A, you can see, and successor is the excavation block because it was late. Okay, and second delay in the ground floor masonry work, you can see it's a predecessor is the ground floor slab concrete. And next it's because it's a parallel activity block masonry, so we will assign it to successor. Then run the schedule. You can see we have run the schedule, and now you can see after adding the events how many days we have. 133 days. So like this we can create a honor cost delay events. Okay, so now move to the products, and next we will open this construction project contractor cost delay events. Right click, then open contractor cost delay events. You can see delay in the foundation shuttering, then delay in the ground floor finishing. Delay in the shuttering, foundation shuttering, because it's a non-exclusive. It's a contractor cost delay. Then the 1160 ground floor finishing, that is the non-excusable and contractor cost delay. You can see here. So we will add these two events. Okay, uh, in the contractor cost delay events schedule, you can see. So first one is the delay in FDN shuttering. Okay, so let me show you its linking. Predecessor is the ground floor column, and next we have three successors here. Okay, you can see here. Next we have three successors here because Checking is the parallel with the other activities, so that's why we will link parallel. Okay, so after that we will run the schedule, and you can see here it will be added for 2 days. Second delay event, delay in the ground floor finishing. Ground floor finishing, here you can see 5 days for late. You can see here 5 days non-excusable, non-compensable delay, contractor cost delay. So we will add like this: delay in the ground floor finishing. Okay, so it has two predecessor and one is the successor. You can see here. Okay, so it has two predecessor. Okay, so one successor. So then run the schedule. So how many days we have? 128. Note: separate delay events to different projects to that later we can exclude them. We created one project for as-built calculation schedule, and two projects contain honor cost delays and contractor cost delays. Okay, so let me open these three projects. First, you can see as planned, then honor cost delays, then contract cost. Right click and open project. Like this, we can, and for analysis purpose, we can open at a time. We can see this is the plan. 121 days for contractor. Honor cost delay events 133, and contract cost delay events 128 days. So the same you can apply for the as built, then honor cost delays, then contractor cost delays. Right click, then open project, and you also can do comparisons like this. Okay, so now next please, plan duration. As you know, plan duration was 121 days. Actual duration as built calculation schedule uh, are there, 140 days. So 100 out of 101, 121 out of 140. So 19 days in minus means this project took 19 days to 19 days more as planned to complete this project. Okay, calculation number one: honor cost delays were subtracted from the as built calculation schedule. So you can open the both as build schedule and the honor cost delays. Okay, as build and honor cost delays. As build, then honor cost delays. Open. Now you can see 140 actual, and after adding the honor cost delays, there are 133. So according to our calculation, you can see 140 in actual, so 133 for the honor cost delay events. Okay, so there is a 7 days difference. Okay, so contractor cost delay were subtracted from the as built calculation schedule. We open to project as built calculation schedule and contractor cost delay events. Now again move to the projects. It's a as built schedule, then contractor cost delay. Right click, open project. So 140 and 122, 128 days after adding the contractor cost delay events. So 128 out of 140, so there are 12 days. Okay, so next we have the same calculation, but you can see why I just uh, do it separate. Calculation number two, with the actual completion date as day 140, the contractor is responsible for 12 days. Okay, 128 out of 140. Okay, of the project delay. So which could be charged for liquidated damages. Okay, so next, with the original baseline completion date as 140. The owner is responsible for the 7, 133 out of 140 so far the project delay. The owner is responsible for the 7 days, but the contractor is responsible for the 12 days. And you should maintain the delay analysis log, okay, like this. So then you can add in your schedule, okay, as an event. So like this, we can calculate the collapsed as built and as built, but for the schedule delay analysis. Okay, so I hope everything is clear. Thank you so much for watching this video. See you in the next video.